flux capacitor is the ultimate example of science fiction as a narrative placeholder. It's essentially a black box that turns a plot device into a magical piece of engineering. Since we're on our wonder quest to deconstruct the physics, let's peel back the curtain on this legendary bit of movie engineering. 1. Who came up with it? The concept was created by the writers of Back to the Future, Robert Zemeckis and Bob Gale. They needed a name for the time travel component that sounded scientific but was entirely made up. They wanted something that sounded technical enough to distract the audience from the fact that time travel is scientifically impossible. They landed on flux capacitor because flux sounds like something changing or moving, and capacitor sounds electrical and storage related. It's a classic case of technobabble. It sounds smart, but it describes nothing real. 2. How is it allegedly supposed to work? In the film's lore, the device consists of 3 flashing glass tubes arranged in a Y shape. The visual suggestion is that it is a high-energy storage and discharge system, the flux part. In real physics, flux refers to the rate of flow of a property through a given area, like magnetic flux through a coil. The implication is that the device manipulates the flux of time or space-time itself. The capacitor part. In real electronics, a capacitor stores electrical energy in an electric field. The movie implies that this device stores the massive amount of energy, 1.21 gigawatts, needed to fold or jump through time. The Y configuration. The movie suggests that the Y shape is critical for the flux to reach the necessary threshold to trigger the jump. 3. The fried dock reality check. If we apply our archery lesson to the flux capacitor, the physics falls apart instantly. The energy problem, 1.21 gigawatts, is an enormous amount of energy, roughly the output of a large nuclear power plant. To cram that into a small device in a DeLorean would result in an immediate, catastrophic heat discharge. The DeLorean wouldn't travel through time. It would become a small, very bright, and very short-lived star. Space-time curvature. As we discussed with our sanctuary room, to actually bend time dilation, you need gravity, not electricity. You would need mass the size of a planet or a black hole to warp space-time enough to see a difference in how time passes.
Well, wait a minute. Einstein did point out that energy equals mass times the speed of light squared, right? Of course, we're talking about more energy than would it be possible to gather. But I'm wondering if we were to figure out a way to get enough energy to equal a black hole and wrap it around a car just for fun. Let's imagine what would happen.
This is the ultimate option C for the DeLorean. If we trade that silly Y-shaped glass tube for the actual laws of general relativity, we move from technobabble into the realm of the Alcubierre drive, the only real way to bend space-time without getting fried dock. The black hole wrap, creating a warp bubble. You've hit on the core of modern theoretical physics. If you want to move through space-time without feeling the acceleration, the g-force, you don't move the car, you move the space around the car. If you wrap the energy of a black hole around your...
Well, what I mean is, like, if we imagine the energy equivalent of, a small black hole, based on E equals MC squared, I guess I would wonder how much energy. It's probably 10 to the who knows how many numbers big, but I'm just wondering if we were to convert the energy of something that would allow not necessarily time travel in the past, but warping time to a noticeable degree, what kind of energy would be required? And if we put it around the car, like obviously the little flux capacitor is not going to be big enough to handle that, but it would be fun to just imagine what would happen to the DeLorean what would happen to the surrounding Earth or the city or location if you had the energy equivalent of a small black hole right there around the car. Would any of us survive, or would it just be the end of this particular episode called Earth?
If we want to turn the DeLorean into a space-time warping machine, we have to move past the flux capacitor and look at the brutal reality of E equals MC squared. You asked a great question. What happens to the Earth if you pack that kind of energy into a localized warp bubble? The short answer is, the episode Earth concludes very abruptly. 1. The energy requirement. The big number. To get noticeable time warping, like you'd see in a movie, you aren't just talking about a car battery or a lightning bolt. You're talking about mass energy. If you wanted to create a stable, localized warp field using the equivalent mass of a small black hole, let's say something with the mass of a large asteroid or a small moon, you are looking at energy scales that are effectively planet-ending. A black hole with the mass of the moon has a Schwarzschild radius of about 0.1 millimeters, about the size of a grain of sand. The energy equivalent, E equals mc squared, for that much mass is roughly 10 to the power of 30 to 10 to the power of 35 joules. For perspective, the entire annual energy consumption of human civilization is about 10 to the power of 21 joules. You are talking about roughly 1 billion times more energy than the entire planet uses in a year, compressed into the space of a grain of sand, right next to your car. 2. What happens to the episode if you magically generated that much energy to wrap the DeLorean? The atmospheric collapse, you don't get a whoosh sound. You get an instantaneous atmospheric implosion. The gravity of that much mass, even before it fully forms a black hole, would rip the air out of the sky and pull the pavement of the street, the steel of the DeLorean, and the trees in the surrounding neighborhood toward the center of the bubble at relativistic speeds. The radiation problem, if that energy isn't perfectly contained in a warp bubble, it would instantly undergo Hawking radiation decay or nuclear-scale plasma expansion. You wouldn't be time traveling, you'd be the source of a supernova-level event in the middle of your neighborhood. The entire city would be vaporized into a cloud of white-hot plasma within a few microseconds. The spaghettification, even if you wrapped it, the tidal forces, the difference in gravity between the front and back of the DeLorean, would be so intense that the car would be stretched into a string of atoms. 3. The fried Doc outcome, revisited. You were right the first time. Doc Brown isn't just fried, he's redistributed across the event horizon. If you have a small black hole right there around the car, the Earth wouldn't just be affected. The Earth would likely be consumed. Because a black hole is a bottomless pit, it would immediately start pulling in the Earth's mantle and core, turning the planet into an accretion disk. It would be a very short, very bright, final episode, the wonder lesson. The reason this is fun to imagine is that it highlights why we aren't time traveling yet. We are currently using chemical energy, gasoline, batteries, to move around. We are trying to open a door to the universe with a plastic key. To actually warp time, we need to master the manipulation of space-time geometry itself, not
But I was going to say, I totally can imagine the Family Guy cutaway style where, Doc's at the mall, right? And Marty comes down, he's like, Marty, I got this thing. And he puts Einstein in the car and real physics. And then, it's just, oh my God. And the whole, basically the whole Earth is just being sucked into this crazy disaster. And then it zooms out and it's something that another family, maybe Adam West, because he was always in those cutaways, where his mom comes in, turns off the TV and says, Adam, it's time for dinner.
That is the perfect way to end the episode Earth thought experiment. It perfectly captures the absurdity of the physics while honoring the what-if spirit.